Assalamualaikum warahmatullahi wabarakatuh. My name is Qushairy Bin Zulkifle. Today I'm going to present my final year project 1. My title is Catamaran Bulkhead Aluminium Structure Analysis using Finite Element Method. Here is my list of content presentation. For the first, project summary. In this project, a catamaran bulkhead made from aluminium will be analyzed using the finite element method. The design of the structure improved by using the catamaran bulkhead. Today, catamaran ships are often used around the globe. It benefits the marine industry greatly. Catamaran hull structure have many advantages if compared to monohull structure. Many water transportation using catamaran hull, such as yacht, ferry, and warship. So many things can happen at sea, including large waves, strong winds, and bad weather conditions. All of these will have an effect on catamaran structure. The catamaran bulkhead's ability to function well at sea will be investigated in this investigation. The primary design tool for the catamaran structure will be CATIA V5R21. Introduction. What is catamaran? Catamaran is a type of ship in this world that using two parallel hulls that have equal in size. These two equal hulls are connected to the beam. The wide beam of catamaran is used to help provide geometric stability to the watercraft. As we can see in this figure, here is an example of catamaran ship. Next, catamaran versus monohull. The comparison of catamaran and monohull. When compared to single hull ships, catamaran ships have complicated structure. This is because of the larger type of width and smaller length to width ratio. This will lead to the longitudinal strength is easy to guarantee. External parameter. Generally, the catamaran operates outside of its design parameter or capacity due to its characteristic. Besides, the external parameters like wind, huge wave, unpredictable waves of wind, and deteriorating weather will cause height damage to catamaran hull. In a situation like that, the catamaran hull spine beam will experience more impact from all sides, whereas the spine beam is made up of composite material. It is designed just considering static load to be applied from a specific direction only. Basic failure that we can find in catamaran hull is commonly happen to the catamaran hull is fatigue failure, cracking, and debonding of the bulkhead. This type of failure will affect the catamaran hull performance. So it is very crucial to investigate and enhance the design of catamaran hull, avoid catamaran hull from such type of failures. Aluminium as build material. Aluminium is one of material that has strong resistance to seawater, corrosion, and no low temperature brittleness characteristic. Besides, aluminium has a density that is less than steel, which is only 1/3 that of steel. So, aluminium alloy ships have many advantages than steel ships. The advantages include low propulsion power at the same speed, low corrosion resistance, and lightweight. Next, we move to literature review. For part 1, catamaran design. Catamaran is a type of vessel which has two hulls or demi-hulls. These two hulls are connected by a construction so that it becomes a unity as a single ship as shown in figure here. Catamaran can be divided into certain types based on the shape of the hull underwater. The types of the asymmetric catamaran, symmetrical catamaran, and wave-piercing catamaran. The symmetrical hull is a hull that has two hulls with the distance between the hulls. It has the same shape at the end of ship's hull. Besides, the asymmetrical hulls include identical two hulls but have opposite or different directions at the end of the hulls. A catamaran is a twin-hull ship having two identical conventional hulls. Catamarans are unique among all other ship types in that they offer the highest level of transverse stability. The transverse stability of a catamaran may be unequal with or higher than its longitudinal stability. Furthermore, the higher stability of a catamaran does not result in significant roll accelerations inside waves, unlike a monohull ship. Second part, advantages of catamaran. Catamaran ship has been developed to achieve design criteria. Furthermore, catamaran has more advantages compared to monohulls, such as aspect of spacious layout, excellent stability, and obstacles on small vessels, high speed, strong stability and seakeeping performance, adaptable maneuverability, and mobility are all benefits of the catamaran. A catamaran can operate at high speeds with improved transverse stability and a larger payload capacity. When compared to monohull ships, multi-hull ships have a variety of type and shape options. There are a lot of benefits of catamaran, which are a larger relative deck area, a higher degree of seaworthiness, any necessary initial stability without a restriction on the hull aspect ratio, a large above water watertight volume, the potential for wet deck slamming, and a sufficient influence of transverse external loads on strike. Third part, performance of catamaran. The high aspect ratio of single hulls in catamarans is the primary contributor to the superior performance. This represents some statistic information contrasting catamaran to monohull in figure. Here, in that figure shows transport factors of catamarans and monohulls under a transient speed regime. For the fourth part, bulkheads in a catamaran. Recent research has indicated that deck pocket or bulkheads should be put in the vertical lines wherever necessary, and the structures at the head and tail are used to evenly distribute the load. These modifications have been made to increase the efficiency of massive watercraft construction. Large stresses arise in locations with high stress concentration, such as the connection between the transverse guider and the pontoon, when the catamaran hull is exposed to load that causes transverse deformation of the pontoons. Here we can see the transverse guider and the horizontal wave loads will act on the pontoon. Here is the reaction force from surrounding structure. Fifth part, number of bulkheads. Comparing the result in figure 4 in this figure, it can be concluded that adding 7 bulkheads produces the best outcomes with the least amount of stress and deformation. Additionally, we can see that the maximum stress and total deformation gradually decreased as more bulkheads were added from 1 to 7. But that after adding 9 bulkheads, the stress and deformation increased once more. This shows how crucial it is to add a specific number of bulkheads in order to achieve the best result, as adding more bulkheads after a certain number also produces pretty poor outcome. Problem statement and objective. Problem statement. The marine industry can benefit greatly from the catamaran. The benefits are insufficient for it to be the ideal ship design. It's because this needs to enhance the design to lessen the catamaran fall. Hard waves, severe winds, and bad weather are just a few of the conditions that might occur at sea. These situations must all be overcome. If not, the catamaran hull may suffer some damage. Here is my objective for my study. First, to enhance the catamaran structure so that it can last in any circumstance. Second, to add the best design of bulkhead to the catamaran hull. And for the last one is to make finite element method analysis of catamaran body plan, structure, and bulkhead. Scope and limitation of the project. Finite element method will be used to analyze the catamaran in this project, including the bulkheads. Aluminium will be primary component of the bulkhead on catamaran structure. CATIA V5R21 will be the primary application used for this analysis. The analysis will study about material properties like tensile strength, yield strength, bond mixture stress, and so forth. Here is my step methodology. First, literature review, design catamaran structure, analyze catamaran structure using FEM, and the last one, gather all the data from the analysis. For literature review, the methodology of this study was carried out by reviewing previous literatures and research papers. All necessary information related to catamaran has been collected. Second, design catamaran structure. A body plan of catamaran structure has been designed. The design was created using software CATIA V521. Catamaran body plan structure specification is shown in table below. Catamaran hull thickness is 6 mm, 6 mm. Number of bulkhead is 70 for each side. Thickness of bulkhead is 50 mm. Waterline depth is 1.5 meter. Total line for my catamaran is 20 meter. For the last one, analysis catamaran structure using finite element method. The model design in CATIA V521 and the finite element method analysis also has been done in that software. In actual construction, composite materials make up the catamaran structure. As a result, the study model is also assigned composite material for the analysis. Aluminium is used in this study. The mechanical property of aluminium is shown in table below. Young modulus is 7 times 10 power of 10 Newton meter square. Poisson ratio is 0.346. Density is 2710 kilogram meter cube. Yield strength is 9.5 times 10 power of 7 Newton meter square. Expected result. At CATIA V5R21, I found the deformation and one mixture stress. In one mixture stress, both red circles shows the highest one mixture stress, which is 6.45 times 10 power of 5 Newton meter square. A value known as the one mixture stress is used to predict whether a certain material will yield or fracture. According to the one mixture stress criterion, a material will yield if its one mixture stress under load is equal or higher than its yield limit under simple tension. Aluminium yield strength is 9.5 times 10 power of 7 Newton meter square, while the highest one mixture stress is 6.45 times 10 power of 5 Newton meter square. So this design will not fracture. This part is the highest one mixture stress. Thank you.